Okay, I'm going to be referring to this big, long document, Factoring Polynomials. This may take a while, because I'm planning on doing the whole thing in one video. What you're comfortable with, you may fast forward past using the slider on your video player, program. So, I'm not going to do all these examples, but I am going to try to do many of them. Okay, and I'll reference what page I'm on as we go along. I will also be adding examples that you can put into the empty space in your printout of your copy if you wish. Okay, so example 1 on page 1. We've got 18 x to the 4th y cubed plus 12 x cubed yz minus 24 x squared y cubed. Now, the goal here is to undo the distributive property. So we're looking for the greatest common factor. The greatest common factor is going to be made up of the highest number that divides all three terms. If it's higher than 1, we'll take it. Well, these two they're all three divisible by 1. They're even, so they're divisible by 2. They're all divisible by 3, and they're all divisible by 6. 6 is the highest number which divides them all. We also look for variables that appear in all three terms. All three terms have an x in them. All three terms have a y in them. We also take the lowest appearing power. So for the x's, I see x to the 4th, x cubed, x squared. So the lowest appearing power of x between 4, 3, and 2 is 2. For my powers of y, I got cubed, first, cubed. So the lowest appearing power of y is just y. Okay, so what we do is we now proceed to divide this polynomial by the GCF. We're going to do these divisions in our head. Remember, divide the big numbers and then subtract your exponents. So 18 divided by 6 is 3. 4 take away 2 leaves me x squared. And 3 take away 1 leaves me y squared. Okay? 12 divided by 6 is 2. X cubed divided by x squared is x to the 1st. The y's cancel. The z is unaffected. And then minus 24, negative 24 divided by 6 is minus 4. The x squareds cancel. Y cubed divided by y is just y squared. 3 minus 1 is 2. And that's it. We're done. Okay? Now, if you look at page 2, example 2, you will see that 5 is the greatest common factor. So you divide everything by 5, and the variables are unaffected. With example 3, all three terms were divisible by x and x only. So the greatest common factor was x, and you divide all three. You brought all three powers of x down 1 power. Okay, I'm going to move on now to example 4, which is the factor 2x cubed minus 6xy plus 2x. All three terms are divisible by 2, and they all have an x in them. The lowest appearing power of x is x cubed, x to the 1st, x to the 1st, so it's just x to the 1st. So that's the greatest common factor. So, to do the division, so we're going to divide all three terms by 2x. 2 divided by 2 is 1, and I'd have to write 1 if there was nothing else. But x cubed divided by x is x squared. Minus 6 divided by 2 is minus 3. The x is canceled, but the y is unaffected. Okay, over here, 2 divided by 2 is 1, so that would cancel, and the x's would cancel. Why not leave something? So 2x divided by 2x is 1. Okay? Be careful, folks. If there were 3 terms to start with, there need to be 3 terms in parentheses. If there were 4 terms in parentheses, you would need 4 terms. Sorry, if there were 4 terms originally, you'd need 4 terms in parentheses. Okay? You got to make sure that there's something for every term in the parentheses. Okay? So now we're going to move on to page 2. Page 2. So we're on page 2. We've got 5x cubed plus 10x squared plus 3x plus 6. First of all, anytime you're confronted with this type of polynomial, make sure it is in descending order. That means the powers of the variable go down as we go left to right. This one's in descending order. It's 3, 2, 1, nothing for powers of x. Now, what you do is as follows. You factor in pairs. You find the greatest common factor of 2 terms at a time. So for this one, both of these terms are divisible by 5. They both have an x squared in them. So I'm going to worry about these 2. I'm not doing anything with these 2 for the time being. So it's just these 2. These 2 are divisible by 5 and x squared. So I'll do those divisions. 5x cubed divided by 5x squared would leave me just x. 10 divided by 5 is 2. The x squareds cancel. So these 2 are done. We don't need to do anything else with them. Next we do the same thing for the next 2 terms. These 2 terms are divisible by 3. 3x divided by 3 is x. 6 divided by 3 is 2. Okay. So your pair of factors is going to be the binomial that you see twice. X plus 2's. And the other binomial is going to be made out of the 2 common factors. 5x squared and then plus 3. Okay? Example 2. We got x cubed plus 4x squared minus 2x minus 8. So out of just the first 2 terms, I can factor out an x squared. X cubed divided by x squared is just x. 4x squared divided by x squared is 4. Okay? So these 2 are done. And I'm going to ignore these 2 for the time being. So these 2 are done. Going to ignore them until I've got this one taken care of. Now, they both have a negative in them, so I will factor out that negative. They both have a 2 in them. I will take out that 2. Okay? And then negative 2x divided by negative 2 is positive x. And negative 8 divided by negative 2 is positive 4. Matching pair of binomials, that's going to be one of your factors, the x plus 4. And then the other binomial is going to be made up of x squared and minus 2. That's it. You're done. Okay? I'm not going to do example 3. I'm going to make up an example 4. Example 4. So let's say we have 4x cubed plus, or let's see, minus, let me make that x to the 4th, minus 6x cubed minus 2x plus 3. Okay, I'm hoping this works out the way that it does because I forgot to make up that example before I turned on the video recorder. So, both of these two terms are divisible. They're both divisible by 2. Okay, they both have an x cubed in them. Not going to do anything with this part just yet. Now, 4x to the 4th divided by 2x cubed. 4 divided by 2 is 2. X to the 4th divided by x cubed just leaves me an x. Okay? And then minus 6 divided by 2 is minus 3, and the x cubes cancel. Okay? So these two are done. Now, folks, if the third term is negative, you're going to be factoring out a negative. And nothing besides 1 divides these two. So we'll take out the 1. Okay? Nothing divides them besides 1, so we'll take out the 1. And of course, as I said, if the third term is negative, you're taking out a negative no matter what. These two are divisible by 2, so that's what's going to happen. Okay? Now, division by negative 1 makes that 2x, and 3 divided by negative 1 is minus 3. So, my binomial, one of the factors is that 2x minus 3 I see twice. The other one is going to be 2x cubed minus 1. Okay? Remember, if the third term is negative, you must factor out a negative. Okay? It's page 3. So the goal is to undo is to factor trinomials of the form x squared plus 11x plus 24. So example 1. X squared plus 11x plus 24. Okay? Well, your first step is to do x and x. And I need the pair of factors of 24 whose sum equals 11. Okay? So propose and sum. Well, 24 is always divisible by 1. 1 divided by 24 is, or 24 divided by 1 is 24. The sum is 25. That's a no. I need 11. Well, 24 is even, so let's try 2. So 24 divided by 2 is 12, and 2 plus 12 is 14. That's a no-go. Okay? So 24 is divisible by 3. 24 divided by 3 is 8. And 3 plus 8 is 11. That's what we need. So, x plus 3 times x plus 8, or x plus 8 times x plus 3. You'll make those the second terms. And it doesn't matter what order you write them in. Okay? What order you write the factors in. It doesn't really matter. Okay? Example 2. X squared plus 2x minus 15. So, I need the pair of factors of negative 15 with sum equaling positive 2. So they have to be factors of the last term and add up to the middle coefficient. Okay? Propose sum. Let's say I don't already know. Okay? So I know 1 divides any integer. And negative 15 divided by 1 is negative 15. The sum is negative 14. That's a no-no. Well, it's not even, so it's not 2, but it is divisible by 3. And negative 15 divided by 3 is negative 5. The sum is negative 2. That is the opposite of what we need. So what you would do is change signs. So negative 3 and positive 5 would be exactly what we need. So x minus 3 and x plus 5. Okay? All right. So let me get these two off the board. I'm going to go ahead and talk about example 4. So page 4, example 4. Factor x squared minus 9x plus 20. We start with x and x. Okay? Now, I need two factors of 20 that add up to negative 9. Find the pair of factors of plus 20 whose sum equals negative 9. Okay, well, propose sum, if you would not already know it in your head. Now, when I think factors of 20 that add up to any sign of 9, I'm thinking 4 and 5. And that's positive 9. So we change signs. Negative 4 and negative 5 is negative 9. That's what you need. Okay? And it makes sense because for this number to be positive, you need to be able to split it up. For this product to be positive, it's either two negatives or two positives. And since the sum is negative, it's got to be two negatives. So, x minus 4, x minus 5. Okay? Example 5. Y squared plus y minus 12. Well, we're not using x's this time. It's going to be y and y. Y and y. Now, I need the pair of factors of negative 12 whose sum equals plus 1. The plus 1 that you don't see here. Propose sum. Well, two factors, so negative 12 has a lot of factors. So let's say 1 and negative 12, that's negative 11. That's a no. 2 and negative 6, that's a negative 4. That's no. 3 and negative 4, that's negative 1. That's a no. That's the opposite. So, negative 3 plus 4. That's positive 1. So, your factors are x minus, or sorry, not x minus, it's y minus. Y minus 3 and y plus 4. Okay? All right, now not every one of these is going to be factorable. Okay? If you see down here at the bottom of page 4, you might see this little paragraph here. Okay? Not every one of these is factorable. Note, not every trinomial is factorable. For instance, illustration, x squared plus 2x plus 10. There is no pair of factors of 10 whose sum is 2. There's no pair of factors of 10 which add up to 2. So this is prime. Not factorable, also called prime. Okay? So that was page 4. Page 5. Again, we're still referring to the factoring document. The steps are on page 5, the very top. I will be referring to these as we go. Okay? So 3x squared minus 10x minus 8. Now, 3 does not divide all three terms. So what you do according to the steps that I gave you is we'll start with 3x and 3x. Now, they're not both going to be there when it's over, because this would be 9x squared. They're not both going to be there. One of them's going to be gone. Okay? So step 1, start with 3x and 3x. Step 2, multiply 3 and negative 8. The equivalents of A and C. So the first number you see and the last number you see. That gives me negative 24. Step 3, find the pair of factors of negative 24 whose sum equals negative 10. So You're not looking for pairs of factors of this to add to that like you were before. You're looking for factors of this that add up to that. Okay? So a good place to start is the factors that gave you the negative 24 to begin with. So that's 3 and negative 8. That's negative 5, no. Okay, we tried we tried what gave it to us to begin with. It didn't work. So now we'll try others. Well, 1 divides anything, and negative 24 divided by 1 is negative 24. That's negative 23. That's a no-go. Okay, it's even. So let's try 2. Negative 24 divided by 2 is negative 12. And that's negative 10. That's what we need. So we will make those two our second terms temporarily. So 3x plus 2 and 3x minus 12. Now what you do next is look for any pair of factors, any binomial which has a common factor besides 1. These two are divisible by 1, only 1, so that doesn't help. But these two are divisible by 3. So we're going to do that division. Okay? So we will have 3x plus 2, and then 3x divided by 3 is just x, and negative 12 divided by 3 is minus 4. And that's it. We're done. Okay? Page 6, example 2. I've got 10x squared plus 27x plus 5. So I will go ahead and stay on step 3, page 5, to refer to the steps. So stay on page 5 to refer to the steps. We're going to start with 10x and 10x. Okay? And then we're going to do 10 times 5. We will get 50. So first number you see times the last numbers you see, you get 50. Find the, so only one, find the pair of factors of 50 whose sum equals 27. So, propose sum. Okay? So, I'm going to start with the pair that gave me 50 to begin with. So 10 and 5, that's 15. Nope, because I need 27. All right, well, 1 divides anything. And 50 divided by 1 is 50. The sum here is 51. That's a no. 50 is even, so we'll try 2. 50 divided by 2 is 25. Add them up, we get 27. All right, so we're going to make those our second terms. 2x or 10x plus 2 and 10x plus 25. Well, these two are divisible by 2. These two are divisible by 5. Divisible by 2, divisible by 5. So we'll do those divisions. 10x divided by 2 is 5x. 2 divided by 2 is 1. 10x divided by 5 is 2x. And 25 divided by 5 is 5. Okay? And that's it. That's how you would do those. All right, so I'm going to get these off the board. We're going to skip page 7. Skip page 7. Page 8. Okay? Page 8. Difference of squares. Example 1. You got 4x squared minus 9. Now what's happening here is you've got something squared minus something squared. You know you have a difference of squares if you've got two perfect square terms. This is a perfect square term if the coefficients are perfect squares and the exponents are even. The perfect squares are 1, 4, 9, 16, 25. They're the results of numbers times themselves. So 1, 4, 9, 16, 25, 36, 49, and so on. So perfect square term minus a perfect square term, minus in the middle. So you're going to be taking the square roots of both of these. Okay? Square root of 4x squared is just 2x. Square root of 9 is 3. Okay? So your two binomials are going to be 2x plus 3 and 2x minus 3. So square root plus square root and square root minus square root. Example 2. X to the 6th minus 25 y squared. So, perfect square, okay? The square root of x to the 6th, you cut the exponent in half, so that would be x cubed and x cubed. The square root of 25 is 5. Square root of y squared is y. Plus in the middle, minus in the middle. Now I'll put an example 3 over here. Okay, example 3 over here at the edge. 100 z squared, let's make it a squared, minus 169 z squared. Okay? The square root of 169 is 13. So that's why it's the perfect square term, because this has a square root of 13. So, square roots and square roots. Square root of 100 is 10. Square root of a squared is a. Okay, so 10a and 10a. Square root of 169 is 13. Square root of z squared is z. Put a plus in the middle of one and a minus in the middle of the other. Okay? you guys can read, okay, you guys can read pages 9 and 10. Read pages 9, 10, okay? And then this is going to be page 11. The reason why we are skipping page 9 and 10, because other ways to factor these. So it's not essential material in my opinion, okay? So page 11, we're going to be factoring sums and differences of cubes. Okay? So I'll be doing one of each type of problem. And I think what I'm going to do is I'm going to split the board, or split the screen. So a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Okay? And then the other one is a cubed minus b cubed equals, there's plenty of room. I think I'm going to move this over. A cubed minus b cubed equals a minus b, and then a squared plus ab plus b squared. Great, they both fit. So example 1, x cubed plus 8. Now folks, a's and b's represent the cube roots. So a is the cube root of x cubed. b is the cube root of 8. So the cube root of x cubed is x. The cube root of 8 is 2. Okay? So everywhere where you see an A, you're going to stick in an X. Everywhere where you see a B, you're going to stick in a 2. Okay? It's a formula-based system. I would recommend making your trinomial parentheses bigger. Okay, longer, taller, whatever you want, however you want to think about it. Okay, so A is x. You're going to be squaring it. Minus A is still x. B is 2. Plus, and then B is 2 squared. And then clean it up. So you'll have x plus 2 times x squared minus 2x plus 4. All right. Now over here, I'm going to be doing a different example than the one that's on your paper. Example 3. (343) x cubed minus, let me move this over. Example 3. 343 x cubed minus 1,000. Okay, so A is the cube root of this. Okay, the cube root of 343x cubed is just 7x, and the cube root of 1,000 is just 10. Okay, so you will have 7x minus 10 from the A minus B. 7x minus 10. So cube root minus cube root. Make these taller. Now, folks, because this is just, these are more complicated. Because this is more complicated than just a number, I'm going to go with, because this is more complicated than just a number or a variable, I'm going to put it in parentheses. So A will be replaced by 7x in parentheses squared plus A is 7x, B is 10. So it looks like I'm running out of space on the screen. So 7x plus A is still 7x, B is 10, plus 10 squared. Okay, since 10 is just a number, I'm not going to bother with parentheses on it. Okay, over on this end. And then we're going to clean up this mess. So this is going to be 7x minus 10. 7x times 7x is, well, 7 times 7 is 49. And then you're going to have x squared. So 7x times 7x is 49x squared. Plus 70x. And then 10 squared is 100. Okay? These are the hardest ones to do. Okay? All right, so I'm going to get these off the board. And I'm going to go to page 12. Okay, page 12. These are this is multi-step factoring. Okay? So we're on page 12. Example 1. 3x squared minus 3x minus 36. Now this is a 3x squared. And we did a problem starting with 3x squared earlier. But the difference here is that 3 divides all 3 terms. Okay? So the steps per page 12 is factor out any common monomial factor. They're all 3 divisible by 3. So I'll divide each term by 3. And that leaves me 3 times x squared minus x minus 12. Well, here's the thing. This is factorable. 2 factors of negative 12 add to negative 1 are negative 4 and positive 3. So because this was factorable, we kept going. Okay, you always keep going anytime you can. Example 2. 4x squared minus 36. Yes, this is a difference of squares. But there's a monomial factor. So take out the common monomial factor first. They're both divisible by 4. So that leaves me x squared minus 9. when I do the division. That's a difference of squares as well. X squared minus 3 squared. So, square root of x squared is x, square root of minus 3. So plus 3 minus 3. And I'm done. Okay? Let's see, I'll finish example 3 because it's on the same page. Okay, example 3. Example 3. 2x cubed plus 20x squared plus 50x. All three terms are even, so they're divisible by 2. They all three have an x in them. And the lowest appearing power of x is just x to the first. So the greatest common factor is 2x. I'm going to divide all three terms by 2x. So 2x squared cubed divided by 2x, the 2's cancel. I'd leave 1 otherwise, but x cubed divided by x is x squared. 20 divided by 2 is 10. And then x squared divided by x is x. And then 2 factors of 50, and then, 50 divided by 2 is 25. And the x's cancel. Now, having done that, I also check to see whether this is factorable. Can I come up with 2 factors of 25 that add up to 10? Yes, I can. They're 5 and 5. So, 2x, x plus 5, x plus 5. That's it. I'm done. Okay? Example 4 on page 13. Example 4 on page 13. And this is where we will stop. We got x cubed plus 10x squared minus 4x minus 40. Now, there is no common factor for all 4 of them. But we can take an x squared out of the first 2 terms. Now it leaves me x plus 10. The third term is negative, so I'll take out the negative. Both of these are divisible by 4, so I'll take the 4 out. That leaves me negative 4x divided by negative 4 is x. Negative 4 divided by 4 is positive 10. So, I've got me a nice little binomial I'm going to make out of these 2 terms. X squared minus 4, and then the x plus 10 that appears twice. Now, previously we were done, but this is a difference of squares situation. Okay? So, the square root of x squared is x. Square root of 4 is 2. So plus 2, minus 2. Now I'm done. Okay? And that's it. We're going to stop here. You guys can read examples 5, 6, but I'm not going to do them. Okay? And hopefully that covers this adequately.